Here's an application on related rate of change. A 10-foot ladder is leaning against a wall. The bottom of the ladder begins to slide away from the wall at a speed of 1 mile an hour. How fast is the top of the ladder moving when it is 4 feet above the ground? So first step is, let's try to sketch this, right? So let me just make a ground here and then a wall, right? And then we'll make a ladder, right? So let's say this is the ladder which is leaning against the wall. Now what we are given here is that the ladder's length is 10 feet, right? So it is 10-foot ladder. So let's say this is 10 feet. Now in this case, how fast is the top of the ladder moving when it is 4 feet above the ground? So we need to find how fast is this ladder moving when this height or this distance from the ground to top is 4 feet. So let's say this distance is x and that distance is y for us. In that case, when y equals to 4 feet, at that time we need to find how fast the top of the ladder moving. At that time, what is dy by dt? That is what we need to find, correct? That is the question. And we already know that this slides at a particular rate, and the rate is 1 miles per hour. So units are different. Anyway, this is dx dt. Since this is change in x direction, right? So if I take x along my horizontal line, which is the ground, and y along the vertical line, which is the wall, in that case dx dt is the change along x and dy dt is change along y, right? If the ladder is sliding, then we expect negative answer for dy by dt since it is coming downwards. That is the whole idea. I hope you understand the question here. Let's read it once again. A 10-foot ladder is leaning against a wall. So that's the 10-foot ladder leaning against a wall. The bottom of the ladder begins to slide away from the wall at a speed of 1 mile an hour. So that is what we have shown here. How fast is the top of the ladder moving when it is 4 feet above the ground? So at the instance when y value is 4, how fast is it moving, right? It will be moving downwards, but how fast? That is dy dt. That's what we need to find. So that is the question. Now let's write down what we have neatly. That is, one, we know dx dt, rate of change along the x direction, is 1, right? We'll forget about units for the time being, or let me write miles per hour, okay? And we know value of y equals to 4 feet. Now to find the value of x, we can use Pythagorean theorem. So x should be 10 square minus y square square root, correct? So we can say x equals to 10 square minus 4 square in this case. So we are trying to find the value of x at an instance when the height is 4 feet, okay? So that is what it is. So that is square root of 100 minus 16, right? So that gives us 100 minus 16 is 84. 84 means we can have 4 as a factor, so 4 times 21, for square root of 4 is 2, so we can write this as 2 square root 21. So that much is the value of x. So this is all given to us. Now, as you can see from here, the three things in a right angle triangle, that is 2 legs and hypotenuse, are related by Pythagorean theorem, right? So we'll use that Pythagorean theorem and solve this question. So we have our equation, which is x square plus y square equals to 10 square. Now if you find derivative with respect to time, so what we are trying to do now is we are doing derivative, that means differentiate with respect to time. Now when you differentiate with respect to time, you get 2x here, right? 2x and dx dt, correct? Dx dt plus 2y dy dt, correct, equals to 0 since that is constant. Now we need to find dy dt. So let me isolate dy dt from here. So we get 2y dy dt equals to minus 2x times dx dt. Correct. Now we can divide by 2y and isolate dy dt. So dy dt equals to, when you divide by 2, 2 is 1, so you get minus x over y dx dt. So that is an expression which can help us find the answer, right? So let's take it to the right side and solve it further. That is, now we need to find the rate of change at which the top is sliding downwards, dy by dt, at a point where y is 4. So we know y equals to 4, and then dx dt at that time is given to us as 1, and we calculated the value of x is 2 square root 21. So substitute all these values and find dy dt. So we have dy dt at y equals to 4 equals to minus x value is 2 square root 21 divided by y value of 4 times dx dt of 1, correct? So that gives us, that simplifies to minus square root 21 over 2, right? And the units for dy by dt will keep same as the ones with dx dt, correct? Since you can see how the units cancel out, we'll work on that also. This is miles per hour. Now how units cancel out? Let us say the unit here, let me work out the units and show you how units cancel out. It's kind of important to understand. So we have dy dt here, right, equals to minus. So when we wrote x was in feet, right? So we had 4 feet, correct? Y value, sorry, x was 2 square root. So let me just write units here. So x was in feet, y was also in feet, that is 4 feet, correct? 4 feet. But dx dt was in miles per hour, correct? Now in that case, what happened? Feet and feet cancel out, and you're left with miles per hour. So the units will be miles per hour. So I should have written units along with these so that there is no confusion, which I can introduce now also, no problems. So I'm writing here 1, this is miles per hour, right? And this is in feet, and this is also in feet, correct? Now as you can see, feet and feet will cancel and you get miles per hour. So you don't really have to change the units to miles or feet and do that part. That is why I'm showing all this to you. That's kind of very important, right?